Hey everyone, welcome to homework 2.10. All right, so today we are looking at the domain and range of functions and what makes sense for a domain and range. So what is allowable given the constraints or information in the problem. So the cost for an upcoming field trip is $30 per student. The cost of the field trip C, so this is the function C in dollars, is a function of the student's X. That's the input. So input is X, the number of students. And then the cost is our function. Select all possible outputs for the function. So if we were to put anything in for x, it would be times 30. So any outputs have to be multiples of 30. So as an example, if I were to put one student in there, it would be $30. If I put two students, it's 60, 90, 120, etc. And so 30 works, 90 works, and that's it. Those are the only ones that would allow for us to have a whole number person that we would be buying a ticket for the field trip to. A rectangle has an area of square 24 centimeters, so something times something equals 24. Function f gives the length of the rectangle in centimeters when the width is w centimeters. All right, so function f is the length, and then our input is the width. Determine if each value in centimeters is a possible input of the function. So we know that it is not possible to have -6 for our width, right? And so we could have 0. It'd be weird though, because that wouldn't really be a rectangle. If we were to have 48, that would mean that the other side would have to be 0.5. So that is possible if we have a very skinny rectangle of 0.5 times 48. Same thing, 0.5 would, on one side, would give us a very skinny side and one very long side. And then the other is 3. And so if we had 3 times 8, we could have 24. That would work as a function of our rectangle. Select all possible input-output pairs for the function y equals x cubed. So if we were to input -1, would we get -1? Yes. -1 times -1 is +1, times another -1 is -1. If we were to put in -2, it would be -2 times -2 times -2. That would give us a positive and then a negative, so this is not going to work. 3, 9. So 3 times 3 equals 9, but this is cubed, so this does not work because it should be 3, 27. All right. 1/2 times 1/2 times 1/2. 1/2 times 1/2 is 1/4 times another 1/2 is 1/8, so this one works. And then 4 times 4 is 16 times 4 is 64, so that works. And 1, -1. This would not work because 1 times 1 is 1 times 1 is 1, +1, so that is not it. So 1, 4, and 5 are your best answers for that. And again, the way to figure that out is just to plug in those inputs and see what you get for your output and whether or not that works. All right, number 4, a small bus charges $3.50 per person for a ride from the train station to a concert. The bus will run if at least 3 people can take it, and it cannot fit more than 10 people. All right, so our riders for n are going to be less than or equal to 10 and greater than or equal to 3. And then it says function B gives the amount of money that the bus operator earns when n people ride the bus. Identify all numbers that make sense as inputs and outputs for this function. So for inputs, we have any numbers between 3 and 10. For outputs, we are going to be multiplying B of n times 350. So 350 times 10 gives me $35. And then if only 3 people ride, 3 times 350 is 1050. So our outputs could be anywhere from 35 to 1050. So then it says sketch a graph of B. So if I have first of all, I can't have 1 or 2 people riding. I have to have at least 3 people riding. So if I have 3 people riding, it costs $10.50. That's just above the 10 there. If I have 4 people riding, 4 times 350 gives me 14. So 4, 14, just above 15 here. 5 people, 5 times 5 times 350, sorry, is 1750. So here-ish. And then 6 times 350 gives me 21. So the graph just above here. 7 times 350 is 2450. And then 8 times 350. So you're just going and creating basically a table of these values. 9 times 350 gives me 31.5. And then we know that 10 times 350 is 35. So these are the possible inputs and outputs. Notice I'm not connecting the dots here because we can't have, 3.5 people. As we discussed in class, we're not counting fractional people, okay? All right, two functions are defined by the equations f of x equals 5 minus 0.2x and g of x equals 0.2 times x plus 5. Select all statements that are true about the functions. So for f of 3, if we were to plug in 3 for f of x, we get 5 minus 0.2 times 3. 3 times 0.2 is 0.6, so that would be 5 minus 0.6, which is going to be 4.4. That is greater than 0, so that is true. F of 3 is greater than 5, so here we get 4.6, I think I said, or no, sorry, 4.4, and so that is not greater than 5, so that is false. Okay, so the next one is g of 1, which means I'm looking at function g. So I'm plugging -1 in for x, 0.2 times -1 plus 5. And so this would be 0.2 times 4, which is going to give me 0.8. And that does equal 0.8, so this is true. Okay, so for the next one, the way that this is different is we're plugging in numbers for f of x and g of x. So we have -1, so g of -1, which we actually just did, is 0.8. And then we're comparing that with f of -1. So f of -1 equals 5 minus 0.2 times -1, which will be 5 plus 0.2. Because a negative times a negative gives me a positive, so it'll be 5.2. So 0.8 is less than 5.2, so this is also true. For the last one, it says that if you plug in 0 to both of them, that these functions will be equal. So you try that one. This one I need you to decide on your own if it is true or false. Number 6, the graph of a function passes through these 2 points. Use function notation to write information each point gives us about the function f. So you can say f of 0 equals 3 and f of 4 equals 6, right? Using our function notation, that's when we have this letter outside the name of the function outside of the parentheses. The input goes here, that's the x value. The output goes here, that's the y value. Number 7 says match each feature of the graph with the corresponding coordinate point. So the maximum is this point right here. It's the tallest point, and that is 4, 16. The minimum is our lowest point, which is approximately here at 1.5, 2. The vertical intercept is where it crosses the y-axis, so that's here at 0, 7. And then the horizontal intercept that never crosses the x-axis here, so there's no horizontal intercept. All right, our last one, the graph shows the audience in millions of 2 TV shows as a function of the episode number. For each show, pick 2 episode numbers between which the function has a negative average of change, so where we're seeing a decline in watching, and estimate the average rate of change or explain why it is not possible. All right, so between this and show A, between these 2 episodes is where we would see the most negative change. Otherwise, everything's very positive, right? And then here is where we see another negative dip. So you're looking to see what is the average rate of change. And so we're looking at between the episodes. We're assuming this is episode 7 then, and episode 8. And it's kind of hard to tell exactly, but let's say this is like 1.6 and 1.5, or maybe 1.7 and 1.6. So 1.7, our later value is 1.6. So 1.6 minus 1.7 divided by 1 episode. Okay, so that's going to be a pretty small rate of change there. But it is negative because we're subtracting a larger number from a bigger number, or sorry, a larger number from a smaller number. So it is a negative rate of change because we're showing a decline. And then here we see a much greater dip, and so you're going to set yours up between episodes 5 and 6. So 6 minus 5 is going to be 1 because we're only looking at the difference of 1 episode. And then you're also looking here from maybe about 5.5 to our second value being about 3.75. And so again, you should be getting a negative result, and this is a greater negative change, and so you'll see that reflected. So you do the calculation for this top portion here, so remember to use your formula. This is where we're getting that information to calculate our average rate of change. All right, so I am going to go over parts of the classwork now. We're going to start with this campers piece. And it says function r is defined by r of n equals 40n. So the r of n is what we are getting as an output, and then 40 times n is where n is the number of campers. So is 20 a possible output? So if we were to look at output, we're replacing r of n. So 20 equals 40n. If we were to calculate this, then we would get n equals 1/2. And we can't have that's incorrect. Moved a little too fast. There you go. We would get n equals 1/2. That's still correct. And we cannot have half of campers, half a number of campers. Remember, no fractional people. We're not doing that. And so that wouldn't work for 20. If we were to have 100 equals 40n, again, we know that 40 does not go into 100 evenly. We would also get a fractional number, and so 100 is not possible. No, because people can't be counted as fractions or as decimals. All right, they have to be integers. It says here are two graphs that relate number of students and camp revenue in dollars. Which graph could represent function r? So as we just discussed, we can't have any half people or quarter people. And so this line includes every space between the whole numbers here. It includes 1/2. It includes 3/4, right? And so this graph would not be it. It would be this graph that shows us that. And the reason is this only shows integers for the domain, as well as it meets the criteria of the number of campers that are allowed to attend this camp, right? Ranging from 5 to, I believe it's 16. Describe the set of all possible values of R for outputs. So outputs, we could go 200. We have another output of here of just beneath that. If we're using 40n, say it is 6 times 40, which will give you 240. So that makes sense there. That's another output. And also looking at then doing the next one, 7 times 40 would be 280, then 320, right? And so it's going to range from, we could say, let's see the R of n. R of n is going to be less than or equal to our greatest amount of 16 times 40 is 640. And then greater than or equal to, if our least number of people is 5, 200 in multiples of 40, because we're going up 40 each time we add a person. If the camp wishes to collect at least $500 from the participants, how many students can they have? Explain how this information is shown on the graph. So if we want to get at least 500, right, then the amount has to be above 500. So we're looking at where it starts here. This is 14, 13. So 13, 14, 15 are 16 people. 13, 14, 15, or 16 people. Because this is where the y value is greater than 500. All right, so for this part here, you do not have to do this. If you do this, it is extra credit. But what you're going to do is substitute these values in for x to see what you get and fill out your y value or your function value, your f of x. So negative 10 minus 2 is negative 12, so this would be 6 over negative 12, which is negative 1/2. 0 would be 6 divided by negative 2, which is negative 3. 6 divided by 1/2 minus 2. This would be 6 over 1/2 minus 4 over 2, or 6 over negative 3 over 2. Remember, when we divide fractions, we keep change flip or multiply by the reciprocal, so negative 2 over 3, and we would get negative 12 over 3, which equals negative 4. Now what happens when we put 2 in here, we have 6 over 0, and we are not allowed to do this, so there is no answer for that. And then 6 over 8 minus 2 would be 1. So it says use graphing technology to graph function f. So I went ahead and I graphed this on Desmos to show you. And so if you see on Desmos, what happens is right at where the 2 is, so this is where x equals 2 is here, right along this line right here, the lines are getting close to x equals 2, but never touching where x equals 2. And so that shows you that the graph is split around x equals 2, right? It's going down on the one side and then up on the other side, but it is never actually touching x equals 2. All right, you can try 3 and 4, right? Sorry, 3, 4, and then this last piece here. Use a calculator to compute the value and see what the calculator says. So if you put that into the calculation, if you were to try 6 divided by 0, what does the calculator say? Okay, try it and see what happens. If I do it in my iPhone calculator, it just says error. But try it on your calculator, see what it says, and that's because we can't divide a number by 0. And then describe the domain of function f. So the number has to be what related to 2. 2 is going to be crucial to that. So it's going to be less than or greater than, equal to, etc. But what in relation to 2 for that input? Or what can you say it's not able to be? And then describing again why it looks like this, because again, it can't touch that x equals 2. All right, your code word today is Casey's, because I have a Casey's coffee in front of me. So Casey's, that's where I got Liam's brownie today. Happy homeworking, and I'll see you tomorrow.